This is my wife's garden pond. She's got a couple fish in there. I don't know if you can see them or not. They're orange. We also got a couple bullfrogs that come around here. And I know I've seen some tadpoles in here before. Hang on. I know where we can find one. Here it is. It's the Armattan TADPOLE, 2.5-inch version, and today we're going to build it as part one of our Micro FPV Drone Build series to help you build your own high-performance, smooth-flying, HD video-capable Micro FPV drone. Sound like fun? Then hit that thumbs up button below and subscribe to your TMac FPV channel, your home for your journey to better FPV fun, flights, and racing stuff. Okay, these are all the parts I'll be using for the build. There are links in the video description below to all of them. We've got the Armattan 2.5-inch tadpole frame. Comes with nice instructions. The Beta FPV Toothpick F4 20-amp all-in-one version 3 board. By all-in-one, in this case, it means the flight controller and ESC together. It doesn't have an integrated receiver or a VTX, which I actually like because that means I can use my TBS Crossfire Nano receiver and this ESC Nano video transmitter or VTX. It's power switchable from pit mode to 25, 100, 200, and 400 milliwatts. On this build, I'm going to try something a little bit different. I'm going to use a split type camera, which captures both your FPV video and HD video at the same time. Normally on my 3-inch builds, I use a Caddx Tarsier, which has 2 lenses, and I love those because the FPV video feed is outstanding, while at the same time you're getting 60 FPS HD video. This time on this 2.5-inch build, though, I'll be using for the first time the Caddx Baby Turtle whooped version, which means it has a 26 by 26 mounting pattern, which should go nicely on top of the Beta FPV all-in-one board. For my motors, since I want to run this on 4S, I'll be using these Emax 1106 4500 kV motors. Now here I need to caution you, because these motor specs state that they're only rated for up to 3S. So if you're going to run them on 4S, you do so at your own risk. I've got a throttle limit set up on one of my transmitter's potentiometer switches so I can dial down the throttle at any time if I choose to do so. If you're interested to know how to set that up for yourself, check out this video on OpenTX throttle control. Lastly, I'll be using a full-speed Lucky Box buzzer. This is one of those buzzers that has its own battery, so if you happen to eject your quadcopter's battery, or aren't able to locate your quad for a while and the quad battery dies out before you find it, this little buzzer keeps going. Depending on how you program it ahead of time to beep, it can last up to 12 hours, so that should give you plenty of time to find your quad. There are other self-powered buzzers out there which do similar things, and I've tried some of them. I use the Lucky Box buzzer as often as possible simply because it has the smallest and lightest form factor, and it works. I've never had any issues with one. Before I begin any of my builds, to keep the wiring as clean as possible and also to keep track of what UARTs I'm using for which of these components, I like to plan out my connections before I start with a simple wiring diagram. So let's take a quick look at how I'm going to connect all of these things together on our tadpole. Here's the wiring diagram for this build. Our Beta FPV Toothpick F4 all-in-one V3 board is here with our Emax 1106 4500 kV motors at each of its corners. I've got my ESC Nano VTX connected over here using TX2 for Betaflight OSD control with IRC Tramp protocol. So we'll activate that on UART2 in our Ports tab of Betaflight and upload the Tramp protocol file in our VTX tab of Betaflight. I'm powering the camera from the VTX with the camera's video signal connected to the flight controller. I'm using UART1 for our TBS Crossfire Nano receiver, so we'll toggle on Serial RX for UART1 in our Ports tab of Betaflight. And I've done our 3-wire connections for our Lucky Box buzzer over here with Buzz Plus or 5 volts, Buzz Minus, and ground. Now a couple things to notice about this layout with this board. It's got LED pads over here, which I haven't used, and it also has another complete UART, UART6, over here, which I haven't even touched. Also, this is one of the 2 all-in-one boards I mentioned in our last video that could fit whoops or toothpicks that has black box capability. I usually start my builds by positioning the ESC on the frame and tinning the motor pads.
Then I loosely place the motors at their locations on the frame, measure out the wires to their locations on the ESC pads, and cut those motor wires to length. Then I tin the end of the motor wires and attach them to the ESC. Then I'll position the flight controller on the frame and use the same sort of process to measure wire lengths for each of the other components attached to it. Today, since we're using this all-in-one board, it's actually easier. We only need to place this CADX Baby Turtle board on top of the all-in-one board. So let's get started.
All right, before we can position the all-in-one board on the frame to get an idea of how long our motor wires need to be, we need to install this optional whoop conversion bracket, which I got because I knew specifically that I was going to be using an all-in-one board. The reason I'm using the all-in-one board is so that I have enough room to put the CADX Baby Turtle on top of it. So I wanted to keep the stack height to a bare minimum so that I can use this CADX Baby Turtle whoop board. In order to do that, I needed an all-in-one board for a one-board solution, and in order to mount this on the Armattan TADPOLE 2.5-inch frame, I needed to get the optional whoop bracket. So let's go ahead and mount this. Since I'll be putting the CADX Baby Turtle board on top of it, I'm actually using longer screws than what came with the Armattan frame. These are 10mm screws, and I think these are 16mm screws. They're a little bit longer. I just need the longer screws so that I can get a two-board stack on top of here. I'm going to insert that. Insert that. Now what I'm going to do is I'm going to put some O-rings on top of this, here and here. Then I'm going to insert these other two screws here and here. Put some O-rings on those. Then I'm going to position our board on top of that. One thing I like about this board is it already came with an XT30 connector soldered onto it. Keeps me from having to do it. And it also came with a capacitor attached to the XT30 and heat shrunk to the power leads. I've also inserted these anti-vibration dampers into the whoop board. So now we got the whoop board in position on the frame, and we have enough clearance underneath between the board and the bracket so that no electrical components are touching carbon fiber underneath. Once we've got all the soldering done, then we can go ahead and place this on top of the whoop board. I'll put some additional O-rings on these as well to make sure that we've got enough clearance between these electrical components and the ones on the CADX Baby Turtle board. So let's go ahead and tin our motor pads. All right, before we get started, these are the tools I use. Links to all of them are in the video description below if you're interested in any of them. I use the CXG E60W variable temperature digital soldering iron. Goes up to a max temp of 500 degrees C. I always keep mine at 475 to do my soldering. I'm sure there are better soldering irons out there. However, this one's worked well for me for over 2 years, and it cost me about $20-25 off of Amazon. I also use MG Chemicals 6337 solder, which is outstanding. Got these angled wire cutters and needle nose pliers to hold the wires while I'm doing the soldering. You always want to have a wet sponge on hand to do your soldering with. That way you can wipe the tip of your soldering iron off when the solder gets accumulated on it. Just take it like this, wipe it off, keep it clean. That way you don't make a mess of your solder joints. Now we're going to place the motors on the arms and measure out the motor wire to the respective motor pads. and cut the motor wire to length, and then tin the motor wires. We don't need to tighten them down all the way. In fact, we don't need to put all 4 screws in. Okay, now that we've got one of the motors in, we can measure the motor wires to their pads, keep the motor wires neat on the arms, run them along the arms, come up from underneath the board, and we know that we need them about that long. I'm going to cut them there. Then we'll strip the ends of these wires and tin them. And now we can go ahead and attach each of the motor wires to their respective pads. Then we'll go ahead and do the same for the other 3 motors. We've got all the motor wires soldered on. Our next step is to connect the VTX to the all-in-one board. I've already measured the length of the wires I need for where I'm going to position the VTX, which is going to be up front here. And these wires, according to our diagram which we made earlier, need to go to these 5 pads, starting with 5 volts. 1, 2, 3, 4, 5. And once again, this UART 6 we're going to leave open. So we're going to tin these 5 pads here and the ends of the VTX wires. Let's go ahead and do that. We'll also tin these wires that the camera is going to connect to. And now we'll just go ahead and connect the VTX wires to the pads. Alright, now before we solder these wires onto the pads, you'll notice this VTX doesn't have any heat shrink on it. We need to fix that because this VTX is going to be sandwiched in between the top plate of the quadcopter frame and the camera board from our CADX Baby Turtle. So we want to put some of this clear heat shrink on it. I think I got this stuff from Progressive RC. We also want to make sure that we've got our antenna on and in the position that we want it to be before we put heat shrink over it. Just like that, so the electrical components aren't hitting the carbon fiber frame of the top plate or any electrical components that will be underneath it from the camera board. So we'll go ahead and heat shrink that. And now we'll go ahead and solder the VTX wires onto their pads. I'm going to have the VTX sitting in the quadcopter like this, so I'm going to have the wires going back down under, and this 5-volt wire is going to go right there. Alright, now our VTX is soldered up to the all-in-one board, and we're ready for our next step. All right, now what I want to do is I want to attach the camera plate and the tail posts to the frame, and then we'll mount the camera in the camera plate, so I've got an idea of how long these wires need to be before I connect them to the VTX. Let's go ahead and attach the camera brace and the tail posts to the frame. Got it. All right, put this like this. This is going to go on top like this. So these wires, I'm going to snip these off right at the end here. We'll tin these up, connect them to the VTX, and we should be good to go. All right, now we have the tail post and the camera brace attached to the frame, and I've connected the camera video wire to the all-in-one board over here. We just need to solder up the ground and the power from the camera to the VTX wires. So let's go ahead and do that now. Now anytime we have a bare connection like that, we want to put heat shrink over it or some liquid electrical tape. I've already run the heat shrink down here over the wires, so we just slide that up over that bare connection for both of them, and then shrink it with our heat gun. So we need to connect the buzzer up to the front left over here. 3 wires, ground, buzz plus, buzz minus. So what I've done is I've run those 3 wires from the back, because I'm going to strap the buzzer to this back arm underneath the flight stack out the front, and then I'm going to connect these wires from underneath the flight stack to those pads I just mentioned at the upper left of the flight stack. So let's go ahead and do that. That goes right there. I've got white, black, red, which we can connect to our buzzer. Black wire, the ground, goes next. Then buzz minus goes right here. Now we've got our buzzer good to go. Now's a good time to check out the electronics, make sure that we don't have any short in them. And we do that by connecting our smoke stopper to the quadcopter and plugging in the LiPo to the smoke stopper. If everything's okay, this light will not come on and you'll hear a few tones. If we have a short in the electrical connections, when I plug this LiPo in, this light bulb will light up. So let's hope that doesn't happen. So here we go. Oh, it's good to go. Alright, then we just align the motor wires along each of the arms and tape them up with this Emax fabric tape, which I've already done on 3 of the arms. I want to tape it down close to where the motor is mounted. And the reason we're doing this is so the motor wires don't get snagged on anything while in flight. And then closer to the base plate. Like that. Now I've got all 4 motors wires taped down on the arms. I'm going to zip tie this, put some double-sided tape on the back of this, tape it to the arm here. Make sure it's not too tall for the prop. At this point, I believe we're ready to put on the top plate. Okay, this is the Video Aerial Systems X-Fire Pro 900 megahertz antenna for the TBS Crossfire system. This antenna was designed to be cross-polarized, which means that it eliminates nulls during flight. So you're actually going to get, by design, better reception. I did a video on these antennas a while back, and ever since then I've been using them on all my quads. I like them a lot. Since this is at 900 megahertz and this VTX antenna is at 5.8 gigahertz, what we're going to do to mount this antenna using 2 of these holes is to zip tie it to the VTX antenna. There should be no interference between the 2, and I've mounted it this way on my other quads, and I can verify that, in fact, there is none. So let's go ahead and zip tie this to the VTX antenna. There's 1. There's 2. Snip these off. Like that, and it actually keeps the VTX antenna more upright as well. So there we have it. We're done with our tadpole build, and we're ready for our beta flight setup, which we'll save until next time. So that's our Armattan TADPOLE build. I thought it went swimmingly. Let me know in the comments below what you think of it. Remember to join me next time when we set her up in beta flight. Until then, make sure to check these out next. Thanks for your time. I'll see you next video. Clear skies, friend.